Hi, welcome to Advanced Credit Program on Embedded Electronics Development. Start your IoT journey here. I, Dr. Sukhpreet Singh from the Department of Electronics and Communication Engineering, welcome you once again on this Advanced Credit Program. As in the last session, you have gone through the Arduino library concept and you have seen how to install these libraries. So libraries are used to basically extend the Arduino environment, the functionality of Arduino environment. So in this session, in this video lecture, I'm going to show you how to utilize these Arduino library to develop the Arduino programs. So in this, we are going to create a temperature detector and display circuit in which we are going to interface a temperature sensor and a liquid crystal display, and we are going to measure the temperature and we are going to display the measured temperature over the LCD liquid crystal display device. So for that, we have to utilize the LCD libraries. So I'm going to show you how we can design this project over the Tinkercad environment. So this is my dashboard of Tinkercad environment. So first of all, as we have discussed, we need to log in here. So I am already logged in with my name, with my account. So you have to create your account here, or you can log in through the Gmail. And afterwards, go to the circuits here, and we need to create a new circuit. Click over create a new circuit. This kind of window will appear in front of you. So first of all, I will give the name here. The name of my project is temperature detector and display program or project. So this will use the display. This is use the LCD display, and it will use LCD library in order to control it through the Arduino. So let's see how we can create this project. First of all, what are the hardware components required to build this project? First of all, we need one Arduino. So first I will select the Arduino part here. So it is appeared here. I will select this and I will drag and drop here. And afterwards, I need one breadboard where I will create my circuit. I will search for breadboard. And it will show me here. I will select this and I will place it over my workspace area. Simply drag and drop functionality. And afterwards, what I need next, I need LCD. So I will select one LCD of 16 cross 2 and I will connect it over my breadboard. And after that, next I need potentiometer to control the contrast of my LCD. I will place this potentiometer here. So you can place anywhere over the breadboard. Let I am placing here. Right. So next I need one resistor for LCD anode and cathode here. So I can let it here. All right. And what else I required? One temperature sensor, because we need to detect the temperature and we need to display it over the LCD screen. So I'm going to use temperature sensor TMP36. So I will show you the data sheet of this also. I'm going to use this temperature sensor. So this is my LED temperature sensor I have placed over the breadboard. Now first we have to make the connections here before we'll write our program over here. So first I need to make the connection. So I'm using the LCD in the 4-bit mode. As we have seen, it can either work in the 4-bit mode or 8-bit mode. If you see here, if I make a closer zoom in here, you can see here DB node to DB7. So 8 data pins are there. Either I can work in the 8-bit mode or 4-bit mode. As I'm going to make it work in the 4-bit mode. So I will use the 4 pins DB4, DB5, DB6 and DB7. So these are the data pins and I'm going to use the control pins here. So 3 control pins are there: RS, RW and enable. So from there, RW is always connected to the ground. So I'm going to use, because I'm going to write over the LCD, I will use the RS and enable from here. Next is the ground VCC. This is for the contrast control. This is for the LCD backlight, LED anode and LED cathode. So I'm going to show you first the connection of this LCD to the Arduino. So first I'm going to connect these control pins RS and enable. So first I will connect my RS pin. I'm going to connect it to pin number 12. So I will start the wire from here and I will make the connection over the pin number 12. So I make the connection over the RS pin, right? Now I will use the enable pin that I'm going to connect over the pin number 11. So I will make the wire from here and I will make the connection to pin number enable of the LCD. All right, so now I'm going to change the color of this wire so that you will able to differentiate between these two control signals. One is the resistor select, second one is the enable pin. Further, I'm going to connect my data pins. I have 4 data pins here. So I'm using the 4-bit mode D4, D5, D6, and D7. So I'm going to connect over the digital pins here 5, 4, 3, and 2. So I'm going to start from the pin number 5. And I am going to connect this pin to my D4. So next I'm going to connect my next pin to the digital pin 4 of Arduino. So your connection should be very clear, very concise. So I'm going to change the color of this also so that it will show me the data lines. So all these are the data lines. Further, I'm going to connect my third data line here to my pin number 6, DB6. And lastly, I'm going to connect my digital pin number 2, my last data line, to my DB7. So I have till now I have made the LCD connection, data pins and control pins. Now further I'm going to make the connection of, I am going to make the potentiometer here for better clarity. Now here on the potentiometer we have 3 pins, terminal 1, wiper and terminal 2. So one terminal is going to connect to the 5 volt and one is going to be connect over my ground. So first I'm going to connect this terminal over my, this is, you can see the rail here. This is positive and this is negative, right? So positive, first I need to make here connection of the ground. So this is my, you can see ground pin. So I'm going to make one wire from here and I will make to the negative rail. And I'm going to give it color black. And further I'm going to connect to this ground of Arduino. So I will take the connection from here. I will connect it to the ground of Arduino. Right? And now further I will connect my VCC to the 5 volt, the positive rail. So I'm going to give it color red. And further I'm going to connect it to the 5 volt of Arduino. And I'm going to make the connection here. So you can escape if you don't want to do the connection in that way. So I'm going to make it to 5 volt. I will continue from here. I will go to the 5 volt supply. So this is me representing me the positive rail and this is negative rail here. So you can see the connection. This is my connected to the positive rail. Now afterwards, potentiometer, one terminal is being connected to the ground and one to the supply. So simply I will connect this terminal to my ground here. So I will, all these are connected. So I will take this wire and I will connect to the ground and making it different color, yellow. And this third terminal I'm going to connect to the positive rail. In the middle, I will connect to the contrast pin of LCD. So this is going to be connect over the here contrast pin, right? So now we have completed the connection of potentiometer also. Next we have resistor. This is used to connect our LED anode and cathode pin. We know that anode is my positive pin, cathode is my negative pin. So negative pin is will be connected to the ground. So cathode will be connected to the ground here. This side connected to the ground, and you can change the color of this also. So this is my negative pin. You can make let the color of this pin ground as a black, and LED anode I'm going to connect over here the resistor. So all these are connected. So resistor, another part is connected to the positive pin. So in this way, I make the connection of the LED anode and cathode pin. Further, only left is temperature sensor that I need to connect here. Now temperature also have the three pins. First is the power pin, then we have V out, third is the ground. So temperature sensor is going to detect the temperature in the environment and convert into the corresponding voltage, and that analog voltage will be given to the these analog pins. 6 analog pins are there. We can use any here. I'm going to use the A1 analog pin, and after that this analog value will be converted to the digital using the inbuilt ADC in this ATmega 328P microcontroller. Then the digital value being processed by the processor inside this ATmega 328P. So I need to do the connections of this temperature sensor. So first I will connect this power that will be connected to the 5 volt. So I'm going to make the connection here, and you can change the color of this wire also. That is positive wire. I'm going to make it red color. So similar, this power I can connect to here positive rail, right? And this ground I can connect to the negative rail. I can make it black color, and the center terminal, that is output voltage, I'm going to connect over the this analog pin. So I'm going to connect it over here. A1, I'm going to take the connection from here, and I'm going to connect over this middle term. So you can change the color of this wire as well. I can make it as a brown. So I hope all the pins has been connected as per our requirement. And read write you can also connect to the ground. So I can connect it to the ground read write pin here. So I can make it as black. So this is our complete circuitry for temperature detector and display circuit. Now further I'm going to show you the code for this. So we will go to this code part. I will select the text here, continue. So because I want to write in whole text, so here I will write the comment. This is my temperature detector and display program. Let user know which part program you write. Always write the comments here. And after that, I need to write here some variable that I want to declare. And the main thing is a library. We are using the LCD library. So we need to include that library here. Hash include. How we can include the library, as we have seen, as include, then library name, that is a liquid crystal C capital .h. So we have included our library here, liquid crystal.h. This is the way to include the library. Afterwards, we will define some variable that we required in our program. One I will declare float. This is the return type. And I'm giving the name value. This is used to store the temperature that we have detected. of float type because temperature can be of decimal points. So return type is float. Name of variable you can give any. I am giving the value. Then I'm going to declare one more variable of int type. Name is temp, TEM, and I'm going to give it to the name A1 because I am going to connect my temperature sensor over the analog pin A1. So I have assigned this A1 to the name TMP, temporary variable. Afterwards, I will start my setup function. In setup function, I will define my pin mode. Pin mode are in the setup function, those instructions are there that need to be executed only one time. So here I need to make my A1 pin as an input pin. So I will make the instruction for the same pin mode. Then I will write here TMP temp. Then I will make this as a input pin because I have connected my temperature sensor here that is going to sense the temperature through which we are giving the input to our Arduino. So that's why this pin will be configured as a input pin. So afterward, this completes my setup function. Then I will write my loop function here, void loop. So in the loop function, those instructions are written that need to be repeat for indefinitely for number of times. So we are going to write first here. We have detected the temperature and the temperature value we're going to store into the variable value. So temperature is the analog sensor. So we are going to fetch the analog value from it. So instruction used for that is analog read. So I'm going to write value. This is my variable in which I'm going to store analog read. Second word R will be capital. Then I'm going to read from TMP. TMP is my A1 pin, that is analog pin, where I have connected my sensor. I'm going to read this pin, and whatever the value I'm reading, I'm going to store into the variable value. And that should be multiplied by, for the scaling purpose, 0.0048. That you can get from the temperature data sheet because we need to do some scaling here. We have read the value in the temperature and we need to scale that value. So I'm going to multiply with 0.0048 that you can get from its data sheet. After that, now I need to scale this value again. Value is equal to value minus 0.5 multiply by 100. Basically the concept is that we have 5 volt maximum analog voltage and digital we have here 10 bit ADC. So that is having the maximum value 1023. So we need to scale that value. So for those scaling, these value you can get from the data sheet of TMP36. We have multiplied first with that we have read value with 0.0048 in order to get the value in the voltage. After that, we have scaled that value into the temperature because we know that for TMP36 per degree Celsius change in the temperature is equal to 10 millivolt. So accordingly, it is multiplied by 100 to get the temperature value in the degree Celsius. So afterwards, now I have to start my LCD instructions. So first of all, I need to set the cursor using the instruction LCD dot set. Second word cursor, C will be capital. Then I have to mention my column number because I have 16 columns and 2 rows. 16 cross 2 LCD is there. So first I mention my column number, let it is 1, comma 1. So both I'm taking 1, 1, column is also 1 and row is also 1. And after that, I'm going to print over the LCD using the instruction LCD dot print. And I want to display message that should be written into the quotation marks that I'm going to write temperature TMP and afterwards I want to print the temperature value that we have detected. I will again use the LCD dot print. Now I will pass the argument value variable here that is containing our current temperature value, and that's our code. So we are going to execute in this code to check our output. I'm going to start simulation. So you can see here our temperature is showing 23.44 degrees Celsius. So we can change the temperature from here because this is into the virtual environment. So whatever the value we are, that according to its data sheet, it can take the temperature value and it is accordingly changing the value. So this is how we can interface a sensor with Arduino and LCD, and how we can use the inbuilt libraries in Arduino. So whatever the temperature it is detecting, that same value is displayed over the LCD screen according to its range of temperature sensor TMP36. So that I'm going to show you if I change this LCD cursor value. So if I change my column value to the let 4,1, or I can say 3,1. So how it will affect my output. So first is representing the column, second is row. So I'm going to start simulate. Now you can see here, my temperature is showing at the third column. This is the 0th column, first, second, and third column. So it is showing my temperature value in the third column. So this is how we can set the cursor according to our requirement. So now I'm going to show you the data sheet of temperature sensor. As you can see here, the temperature can be vary from minus around 40 degrees Celsius to the here 121. So it is the range of the temperature sensor TMP36. So as you can see here, this is my TMP36 data sheet. So its range is from minus 40 degrees Celsius to plus 125 degrees Celsius. So in this range, it can measure the temperature value. So same task is done by our temperature sensor circuit that is being designed over the Tinkercad environment. So students, in this video lecture, we have seen how to use the Arduino library Liquid Crystal to display data over the LCD, and we have created one project in that we have interfaced temperature sensor, and we have detected the current temperature, and we have displayed that temperature over our LCD screen. So this is all about this session. Thank you.